Okay, welcome to our webinar, Import of BIM Data to PTV Viswalk. Just to check, and the question, can you all hear me? I'm talking right now. From what I see, you should be able to hear me because there is a visual feedback in the software. Good, so let's begin. Yeah, before I really show you how Viswalk is importing the BIM data, I'd first like to talk a little bit about BIM itself, since maybe not every one of you is really familiar with BIM and IFC and so on. The very first step is that in this webinar I will use an example file. There are examples online, freely available under the GNU license. You can see it here at this URL where you can download a number of example files of BIM. And what I'm going to use is this file, chassis1.ifc. And we will at first have a look to that file with the XBIM Explorer. It's a software which you can download for free. You can even download the source code and modify it, and that's available here at this URL. So this example file, chassis.ifc, it looks like this. So it's a building, and it's a building with 4 floors, 4 levels, and they are intermingled in a way. There's an underground level, and from that underground level you can see here there is a stair which goes directly to the ground level, but there is also a staircase which leads here via these stairs to the first floor, first upper floor, and the first floor you can see here, and there is a second floor which by stairs leads to the first floor and then down to the ground floor. IFC, so the particular BIM format which Viswalk can import is the open, the free BIM format. The manufacturers of the common large CAD softwares, which you probably all know, they all have also their own proprietary BIM format in which they save their own files. So you as a user, you can save these BIM files. But since the format is not, or the format definition is not available in the public, third parties cannot really make use of it and cannot import it. But these CAD softwares, they all have an export function to IFC, which you can use to save files, which then can be converted to Viswalk geometry and used in Viswalk. And that's what we now will do. So here is Viswalk, and what you need to do as a first step is to import and then BIM IFC. And here is a dialog. It's not only a dialog of Viswalk, it's a separate software, in fact. And the reason for that is that these IFC files, sometimes they can be really large, several hundred megabyte. And just reading these takes time, converting these takes time. And we didn't want to block a license just for the importer. so you can continue working with Viswalk. The other thing is that we only want to convert the geometry, so the file which is going to be created now as input file of Viswalk, it does not have all of these default data, display types and so on, but really only the geometry, only what is necessary, what is required, and this then can be added to your Viswalk model without doubling maybe the display types and this data. Okay, so this is, I'm selecting jesse1.ifc as file to be imported, and I define a name for the converted file, and all other options are options which define which data is going to be converted or imported and how to interpret the data. So for example, here, intersection height in meters, this means that for each level, for each floor, in BIM, the obstacles or the objects, they can have arbitrary three-dimensional dimensions. And in Viswalk, essentially the obstacles, just as the areas, they are two-dimensional. So for each floor, at a certain x, y coordinate, there is either an obstacle or there is none for each z coordinate. So you cannot say, oh, there is an obstacle which is 50 centimeters high, and if you're fit enough, you can jump on it and then walk, but if you're not, you cannot. That's a binary decision in Viswalk, while in BIM, since it's just for visualization or for planning of the structure, it can have arbitrary three-dimensional coordinates, and this parameter we need to change for our model to 0.5, since with this rather complex floor structure which exists in the demo model, 1 meter would be too high and we would miss some of the walls. Now here, chord tolerance, that means in BIM, in the IFC data, there can be objects which are really circles, which are really round, arcs, which are not I get an error message. Okay, can you hear me? I saw an error message just that the audio was interrupted. It seems to work again, so sorry. Okay, so chord tolerance means that when you have an arc which is really defined as an arc and which is not approximated by a polygon in BIM IFC, you need to approximate it with a polygon in Viswalk. You can do the approximation with arbitrarily many vertices, corner points, but it's maybe not necessary to have all too many. So there is a chord tolerance, and the smaller this value is, the closer the approximation will be to the real arc, the perfect arc, the perfect circle. And the larger this value will be, the smaller will be the number of vertices for the polygon which approximates the circle or the arc. So we can leave it to this default number, since in the building which we have as an example here, there are no circles and there are no arcs. Create display types from materials. Well, that doesn't need explanation. Split slabs into strata. Here, this option says if there are areas. So what is an area in Viswalk is a slab in BIM, to put it short. If there are slabs in BIM which have an incline, you need to decide in Viswalk if they should be imported as one piece or as a sequence of pieces. which are terraced. So you split up a slab into which has an incline in, let's say, 5 areas, and each of the areas has a different C coordinate, and in this way pedestrians can also walk on different heights. So the incline in BIM is approximated by a series of flat areas in Viswalk, which have different height but no inclination. We don't need it here as well. Import property sets as user-defined attributes. Since Vissim and Viswalk 7, you can have user-defined attributes, and this can be used to import whatever properties there are for the BIM model to include these in your model, even if you don't need this for simulation. So it's just for information then, but you have access to this information in Viswalk. You don't have to go back to the BIM model. Yeah, what do you want to import? Of course, the floors, the slabs where pedestrians walk on as areas. Normally you will want to import these. Import as obstacles. Usually, of course, you want to import the walls, wall standard cases, and so on. And then there are some objects like windows, columns, curtain walls, blades, and so on. Sometimes you will want it, sometimes not. So you have the option to do so. And then, of course, import stairs as stairs, yes, and import ramps as ramps, yes, as well. So we can run the conversion. That's what you see here. There's a number of messages which shows you if all goes well. And so here we are, conversion finished, close, and we can quit. You don't see the model here because it's not imported directly into the Viswalk which you have open, but we need an additional step with read additionally, network, and here is our file which we have created. IFC import webinar, okay, open, and these are the objects which we want to import, and here is the model. We can see this better if we have a second editor where we just look at it in 3D. And as I said, there's a piece which is underground. It's better if we switch off the land display. So you already probably recognize the structure with the building which I've shown you before in the XBIM Explorer. So here is the back stairs on the back entrance. Here is the main entrance, the underground level, and so on. And all is easier visible if we just reduce the height of all obstacles, of all walls by a factor of 3. That makes it easier to see everything. Otherwise, the walls would just occlude too much of the area. So basically, that's the BIM import, and we could finish here now, but I'd like to show you that really you can use this to do a simulation. And so I just add the most basic elements which you need to run a simulation. So at first, just an outside areas which we use as destinations for the routes. So let's have an area here on the base level, create an input and a route from origin to destination, Let's do the same in the underground level. You could use, of course, these areas which have been imported as well to create inputs and routes there, but I prefer to separate the functions and have areas where pedestrians walk on, and also have areas which are used for other functions, namely to hold an input, to hold route decisions, and so on. So that should be not on level 0, but on level -1. Okay, otherwise there will be a problem. That was level -1. Let's go to level number 1. Let's have an area here with a route and an input. And finally, as well on the second floor, good. And the last thing we need to do is define some input volume for all these. Let's have plenty of them. So here they are. So that was the quickest way to do a simulation. And you see there's really maybe some too many pedestrians. Let's have fewer. And you see them walking. Let's go through the levels, level by level. So switch off level 2. And level 1. So here we see pretty good now the underground level and the base level. And back with level 1 and level 2. That's it already. So do you have questions? So it's fairly simple, as you see, as it should be. So I see the question, how large is the BIM file which can be imported? There is not really a limit to it. As I said, the larger it is, the more time it takes. But we haven't seen a limit to the size of BIM files which can be imported. Technically, we didn't include a license limit, which would pose a restriction. So you can try. If you have doubts, just try. There is also, apart from the converter, which has a user interface, there is a delivered with the setup a command line tool which does the conversion, so you can create your own batch files, and all of these options which I've shown you, they are also available as command line options, and you can run it overnight and convert in a sequence 20 or 100 files or whatever. And that can be very helpful, especially if you are unsure about this intersection height. What would be the ideal value for that for your files, and you can just do in a sequence and convert the same file, let's say 10 times, and then see which is the best result. Good. Any other questions? Yes, the question why I did create additional areas, although the areas were already imported. That's what I said. That I prefer to separate the functions. So I prefer to have areas where pedestrians walk on, and then for input and route decisions and route destinations, I prefer to have separate areas which are totally included by the walking areas and where I place on these functions of input and route decisions and route destinations. And of course, these functional areas for input for route decisions, they are not included as information in the BIM file, since the BIM file was not created for usage with Viswalk. So I have to add them manually afterwards. But in this way, I stay more flexible for the further progress of the project, since I know, okay, these are the areas and they are unmodified, which came from BIM. And these are the areas I have created myself manually. So I somehow keep the two sets separate. And that, I think, makes it easier for the later project to go on. Okay, another question for the importance of the intersection height. Yeah, the intersection height. The Viswalk simulation, although you see here, you see it in 3D, the Viswalk simulation, essentially it is two-dimensional. So the pedestrians are modeled in the XY plane for each level. And then you have to decide, is there an obstacle or is there no obstacle in the XY plane? It's not possible to have an obstacle which is just 50 centimeters high and some pedestrians can jump over it and some can't. Either it is an obstacle or it is none. You can give it a height and you can give it a Z offset for visual display, but when it is there, it is an obstacle, even if pedestrians could walk over it visually, if it looks like they could walk over it, or if it looks like they could walk underneath it. If it's there, it is an obstacle in the simulation. Now in BIM, the obstacle can go, let's say, from a Z coordinate 1 meter to a Z coordinate of 2 meters. And a real person could rob underneath it, for example. But such rather odd ways to move are not implemented in Viswalk. Pedestrians walk upright, they cannot crunch, they cannot fall, and so on. And therefore, we have to limit a bit the freedom the architects take for them to get the data into a form which can be used by Viswalk. And that's the two-dimensional form, that the Z coordinate is only there for visual purpose. Apart, of course, having having various levels. That's the real third elevation dimension in Viswalk. But within a level, it's two-dimensional in the simulation. Yes, a question for the BIM data, which I've seen in the beginning on these web pages. Yes, the web page which I've seen, this BIM data is under the GNU license, so there are some restrictions. You have to name the source, you have to name the license. Any derived work, if you publish it, would again be under the GNU license, and so on. But apart from that, they are free to be used, so there is no license fee which you have to pay. So the question is, can we use it in our projects? Yes, I mean, your project will have different different geometries probably, but as a demo project, yes, you can use it if you name the source and if you say that's the original file was under the GNU license. Is the BIM file editable? Yes, the BIM file can be edited in a way. I did edit it with Viswalk. Viswalk is not yet able to save it back to BIM format. The BIM file, the BIM format is also editable by CAD software, which is available, AutoCAD, Vectorworks, Graphisoft, and so on. They can read it, you can edit it, and you can save it back to IFC. So that's possible, yes. And change the position of stairs. Yes, you can change the position of these stairs. So I didn't show that. So I can, of course, I can move around the objects in which are in the file. Now, of course, the file is broken and I cannot use it for a proper simulation anymore. But as you see, it's not fixed, so I can take it into pieces and modify what has been imported. Maybe a final word on the colors which you see. Gray means area, green means obstacle when it was imported from BIM. Red does not necessarily mean stairs, but red means there was some property in the BIM file which you should check if it was imported correctly. That often happens with stairs because stairs have more properties than areas, number of steps, the width of steps, the depth of steps, whatever. And with stairs, the exporting tools often do not comply to the IFC standard, or it could be that one or another property is not yet understood by Viswalk properly. And so if something is imported with and shown with a red color, it means if it looks, particularly if it looks strange, double check if it was imported correctly. And the reasons for that can be manifold. It could be just in the file, it could be in the exporting tool, the CAD tool, or it could be on the side of Viswalk. Okay, I don't see further questions, so I'm looking forward to seeing you use the BIM importer, do projects, publish the results, and I'm also looking forward to the progress of the BIM and IFC technology. It's a very dynamic field as I see it. The standard is evolving, and also for us that means that the future will bring probably further options to improve the tool. And so thank you and goodbye.